So now that we've talked a bit about reactive streams and the reactive programming principles, let's get a little bit more specific and start talking about the Reactive Streams API. And of course, the Reactive Streams API is an implementation of the Reactive Streams principles that appears in Java, starting with Java 9. And we'll talk about some of the key abstractions that are available, including publishers, subscribers, and subscriptions. So Java 9 supports reactive programming by the Reactive Streams paradigm and something called the Flow API. And if you take a look here at this link, you can find what the Flow API is. Before we get into the details of the Flow API, let's first give a higher level view of what Reactive Streams is doing in Java. So if you recall, up to this point, Java had Java Streams and parallel streams and completable futures, but it didn't have reactive streams. So what is reactive streams relative to those other things? And basically what reactive streams are a stream-oriented pub-sub model based on the publisher-subscriber pattern. And here's basically how this works. It combines two patterns. The first pattern is the iterator pattern. And what happens here is it applies a pull model where application subscribers, these guys, ask the publisher to send them a certain number of items. So basically they inform the subscriber or subscribers, inform the publisher that they want to receive a certain number of items. So that's basically kind of a pull. It says like, please send me 10 items. So that's the iterator pattern. And then the second pattern is the observer pattern. These are both, of course, Gang of 4 patterns. Hopefully you're familiar with them from other courses you've taken here. And the observer pattern applies a push model that reacts when a publisher source pushes an item to a subscriber sink. So over here, after the publisher has been told by the subscriber, I can take up to 10 items at a time, then when it gets access to items, it could be, say, monitoring a temperature gauge or a pressure gauge or a Twitter feed or whatever, it then goes ahead and says, I've gotten items or one item to emit. I'm going to go ahead and send or publish the items to the subscriber. So you can see here that the dashed line from subscriber to publisher is a control line that says, here's how many things I can take, which could be actually as many as you can send me, or it could be send me 3 or 10 or 20. And then there's another line, which is the blue line, which is the data line, which is basically pushing the items from the publisher to the subscriber. So those are the two key patterns that the Reactive Streams frameworks and the Reactive Streams specification and so on define. Now, the way this is actually implemented in Java 9 is through this thing called the Flow API. And the Flow API is a quartet of 4 interfaces that are part of the Flow interface. And this defines a way to ensure interoperability of reactive stream implementations. So you can see here that there's these 4 interfaces. We'll look at them one at a time. One of them is called Publisher, and you can see that Publisher has a single method called subscribe, and that method can be passed a subscriber, so it can record that and keep track of it. You can see the subscriber has several methods. It has onSubscribe, it has onNext, onError, and onComplete. And so the publisher will basically push events to it as they occur through these various hook methods like onNext, onError, and onComplete. We have this thing called a processor, which is both a publisher and a subscriber, and that gets used as sort of intermediate stages in a pipeline between the source publisher and the sync subscriber. You can have these things in the middle that do processing that are both publishers and subscribers. And then the last piece is something called a subscription, and that basically is a way for the subscriber to tell the publisher how many events it requests at a given point in time. So those are the 4 key interfaces that are part of the Flow API. Now, we'll talk a bit more about this stuff later. These are very simple, intentionally very simple. And you'll see in practice that the frameworks that we're going to be using, in our case, for example, Project Reactor, have many, many, many more things than just these simple 4 interfaces and the handful of methods that they define. There's literally hundreds of methods that are used in Reactive Streams implementations. But we'll start out with the core pieces. So let's talk about these abstractions, and you'll get a chance to see how they work. So a flow, which is part and parcel of what the Flow API is defining, involves interaction between three key abstractions. And you can tell from the screen here what they are. There's a publisher, and publisher, there could be multiple publishers, but a publisher is a source of events that produce 0 or more events that can be pushed to 0 or more subscribers. So you may have no subscribers, you may have 1 subscriber, you may have 10 subscribers, but a publisher is basically the entity that will emit or publish these events and produce them. And it might produce no events at all, it might produce 1 event, it could produce an infinite sequence of events, it could produce 100 events. That's also left for the application to decide. So that's what a publisher does. Subscriber, so a publisher is a source, a subscriber is a sink, and it basically can be used to register for and consume events that are pushed by publishers. So I think that's pretty clear. Publishers publish, subscribers receive the events, and publishers can push events using a series of hook methods, and you'll see what they are. There's on next, on error, and on complete. A hook method, of course, is just a virtual method call that gets invoked that can be overridden by a subclass or an implementation in order to do something. And you can see here that these follow a particular pattern, literally using regular expressions. You can have 0 or more on next calls followed optionally by 1 on error or 1 on complete call. So what this is saying is you might have no events whatsoever. You might have 1 on next call. That's how data gets sent from a publisher to a subscriber. You could have many, an infinite number of on next calls, and you might have 1 on error call, and you might have 1 on complete call. On complete, as we'll see, is kind of like end of file. It indicates that the stream is done, the flow is finished. And then the third key element here is something called a subscription, and it's used to control the flow of events between a subscriber and a publisher. And in this particular case, when the subscriber subscribes to the publisher, it's going to call back its onSubscribe hook method, and that gives the subscriber a chance to say how many events it wants sent to it. And the reason this is here is to support something called back pressure or flow control. And basically what you can do is you can have subscribers say, only send me n events, where n might be 3, or n might be 10, or n might be 100. And then the publisher is obliged to only send that many events until the subscriber asks for the next chunk of events. Now you can also, as we'll see, say, send me as many events as you can, in which case the publisher can just send them out as quickly as it deems necessary to get the job done. So here's kind of how this works. The subscriber subscribes to the publisher and says, please start sending me data. And thing to remember is a reactive stream, just like a Java stream that we've talked about before, is lazy. So nothing whatsoever happens until subscribe is called. So just like with Java streams, we talked about terminal operations like reduce or collect. Nothing happens until those things start, until they get hit, until they run. Same thing is true with a reactive stream. Nothing happens until subscribe is called. Once the subscriber registers, then this onSubscribe hook method is called back, which enables the subscriber to tell the publisher how many events could be sent. And that causes the subscriber to request the number, which could be n, where n is either 1, 2, 3, 4, 5, up to max value, which is the maximum value of a long, in which case it'll send as many things as it possibly can. But nothing is sent until demand is signaled by this method. Now, let's talk about how data gets sent. The most common way that data gets sent is by calling the onNext hook method. So the publisher, when it has something to do, will call onNext on the subscriber or subscribers, and that will then allow the subscriber to react to what was sent to it. And again, there can be 0 or more onNext notifications, which form what's known as a stream. So all the calls that are made from when the publisher starts to publish until the publisher is finished form a stream. If the stream terminates normally, if it succeeds, if it was able to send all the events that were necessary to be sent, then the last thing that the publisher will do, it'll call the onComplete hook method. And that's basically just an indication to the subscriber that we're done with this particular stream. Keep in mind that On complete may never be called. There's no necessary reason why it has to be called. But instead, if it is called, it'll indicate we're done. It's kind of like reading the end of file marker from a Java or Unix file or a Windows file. There's also another method which is called onError, and this is called by a publisher if an error occurs that the publisher is not able to handle. And basically it's a way of being able to propagate an error in the form of a throwable, which is a variant of an exception. It's basically the base class of exception. And that is what's used to indicate to the subscriber that something has happened that the publisher can't deal with, and it's the subscriber's responsibility to do something about it. Maybe print an error message or retry or whatever. So that's what happens when things fail. So we've got notifications. If we succeed, we get on complete. That indicates success. And if something goes wrong, then we have on error, and that indicates a failure. Okay, so that's the end of a quick overview of the Java Reactive Streams API. One of the things you should notice at this point is it's pretty simple, and that's intentional. However, when you start playing around with this stuff in practice, you'll see there's a lot more things that are actually going on, and we'll talk about why that is in the next lesson.